Chapter 9, Lesson 4 is solving quadratics. Today we're going to be focused on 3 different types of quadratics. The first one is where we're just going to have the equation x squared equals a number. There's no b term. So remember we discussed that squaring something and taking the square root of something are opposites. So when we have x squared equals a number, in order to undo it, we're just going to square root both sides. Now, when we take the square root of a number, though, remember there are 2 answers. One's a positive and the other is a negative. The second type we're going to have is what's called vertex form. And so we have something in the parentheses with our x. So we're going to take the square root first, and then we're going to add or subtract to get the x alone. Then the last type we're going to have is a standard formed quadratic. And that one we're going to go back to our last chapter about solving for the binomials that were FOILed to get that, and then we're going to set each of them equal to 0 and find the x-intercepts. So the first one starts pretty easy. We don't have a b term. We just have x squared equals 4. Since there's no b term, I could just take the square root of 4, and it's -2 and +2. On the second one, the first thing I have to do is divide by 16, which is 3. So I have n squared equals 3. And then when I take the square root of that, I get -3 and positive square root of 3. And the second one, when I take the square root of 25, I get 5 and -5. On these ones, the first thing I'm going to do is undo the square root. So I'm going to have 2x plus 1 equals 1, or 2x plus 1 equals -1. Subtract 1 to get 2x equals 0. Divide by 2 to get x equals 0. This one, subtract 1 to get -2. And divide by 2 to get -1. On this one, I'll square root first. So I get 4x plus 3 equals 5. And 4x plus 3 equals -5. So 4x equals 2. And x equals 1/2. Or 4x equals -8, and x equals -2. The last type is the standard form, where I actually have to factor and then solve them for 0. So this one asks me what are factors of 3 that add up to 4, 3 and 1. Sign chart says both minus. So either x minus 1 equals 0 or x minus 3 equals 0. So x equals 1 and x equals 3. On this problem, I have to subtract the 5 first to get it into standard form. So it would give me x squared minus 4x minus 5 equals 0. Factors of 5 that subtract to be 4, 5 and 1. Sign chart says the bigger one gets a minus. So x plus 1 equals 0 and x equals -1. Or x minus 5 equals 0 and x equals 5. On number 7, I have to first set it equal to 0. So that would give me 2x squared plus 11x minus 40 equals 0. There is no greatest common factor, so this is a window method. So I take the 2 times the 40 and ask myself what are factors of 80 that subtract to be 11. (16 and 5). And sign chart says the bigger one gets a plus. This has in common x. This has in common 4. This has in common 2x. And this has in common -5. So either x plus 4 equals 0. So x is -4. Or 2x minus 5 equals 0. So 2x equals 5. And x equals 5/2. Number 12 here, first thing I have to do is take out a greatest common factor of 4a, which leaves me with a squared minus 16. Then I need to set up the two binomials for my a squared minus 16, a plus 4, a minus 4, and don't forget about the 4a out front. So either 4a equals 0, a plus 4 equals 0, or a minus 4 equals 0. So a equals 0, negative 4, and positive 4. And this one told us we were going to have 3 answers because the degree was 3, which means it has 3 x-intercepts. On this one, I'm going to divide both sides by 9/25. So m squared equals 3/25 over 9. And when I take the square root of that, I get m equals 55 or negative 55.